The next way to take a capture is by clicking on the Capture Option button in the top left-hand corner. This will open a window with some of the same information you saw in the main page, but it also offers a few more features, so depending on the issue you're troubleshooting, you could make use of these options. First things first, we'll select our network adapter as we did on the main page. In this case, I have two adapters present. I'm currently using my wireless adapter, so that is the adapter I'm going to select. You'll see an option here to enable promiscuous mode on all interfaces. This is an important option if you're mirroring traffic to the device you're running Wireshark on. What this means is that the adapter will capture all traffic that it sees, not just traffic that is addressed to it. So in an example where you're troubleshooting an issue on a specific LAN segment and you've created a span session and connected a laptop with Wireshark to that segment, you would need this turned on to pick up that traffic as it's not destined, not assigned to this adapter. Default practice is just to leave this enabled, even if you're running Wireshark on the host you're troubleshooting and you're not expecting any other traffic to hit the adapter. It's a better safe than sorry mentality. Moving on, you'll see a filter section here. This is a capture filter section. It looks very similar to the display filter, but it's a little different. What this will actually do is filter traffic before it's captured and saved. So if you only wanted to record traffic from a specific host or traffic on a specific port, you could specify that here. And it will only pick up and save those packets that match this filter. What this is good for is when you have a lot of traffic on the adapter and you only want a small amount of it. It also helps to keep capture files smaller, which leads to easier analysis and saves on hard drive space. One thing to keep in mind with capture filters, depending on the scenario and traffic levels, it's typically easier to filter the traffic after you already have it versus you filter out too much information, too much traffic, and then you look in your capture and you don't have what you're looking for. You would have to run a new capture instead of picking up maybe a little bit more information than you needed, but then you can always filter down afterwards. Um, Say an example, you have a user who's complaining of slow web browsing intermittently, and you take a capture, you filter on their source IP address and port 80 or port 443 traffic, being HTTP and HTTPS traffic. As this is what the user was complaining of, that's a smart thing to filter on, right? However, in this scenario, say you take your capture, you analyze it, you don't see any issues. The user initiates a connection attempt and the web server responds very quickly. Now, what you would have seen if you only filtered on the source IP address of that user and captured all traffic would have been slow DNS responses. Say the user is going to www.google.com. So they would send out a DNS query to their resolver for that URL, and say their resolver is not responding for 10 seconds. That's going to translate to a slow user experience, but you wouldn't have captured that because you were filtering only on port 80 and port 443 traffic. So just something to keep in mind when you're setting these capture filters. Capture filters are something you want to set gradually, or if you're confident on the symptoms and you know what you're looking for. Starting off with, if I'm even going to set a capture filter, you can do source and destination IP addresses or DNS traffic, leaving the ports empty. This could even be too specific, again, depending on the scenario. If there's not too much traffic on the adapter and you're not concerned with hard drive space, you will probably just leave this field empty. So going to the next tab, being output, this is where you can specify the name of the capture, or if you just leave it empty, it'll take a temporary name. These two options here are very handy to be aware of. What these allow you to do are to capture to multiple files and set up a ring buffer, or what some people call a rolling capture. How this works is you specify the size of the capture or how long you want to capture to one specific file. We're going to select this option here, and what I recommend is specifying the size of the capture. Depending on traffic, you'll keep a static file size for each of the captures that you're capturing to. It's not susceptible to traffic levels at that time. Uh, Next, you'll specify how many files to capture to. So once this first capture hits 100 megs in our scenario, it'll start capturing to a new file, and it will do that for 10 files. Once that 10th file hits 100 megs, it will roll over to that first capture and overwrite that file. What this is good for is for capturing in high traffic areas, so it keeps you from filling up the hard drive. It statically assigns how much space you will capture to. It also allows you to keep the files into a manageable size. So if you, again, depending on the computer you have, if you have a capture that is, say, 500 megs, it's going to take you a while to parse through that. Instead of maybe 10 100 meg files, it'll be easier to open, easier to parse through, filter through, those sort of things. This is also very handy for intermittent problems. You can set this capture and leave it running, and then once you have confirmation that the issue has occurred, either a user has complained or an alarm has been triggered, you can go stop the capture and grab the file from that time frame that it occurred. The last tab here is just some additional options. The important options here would be to stop capturing after a static instance, either number of packets, number of files, or number of seconds, if you're not using the rolling buffer, for instance. And then the last option is to hit start, and you are now capturing traffic.